Those are reciprocal. How do you find it? How do you find inverse functions if they say find the inverse function? Yeah, you swap the x with the y with the x. Yes, that means the same thing. So this one, how about this? Literally swap the x with the y and the y with the x. Yeah. The x becomes the y becomes the x. Sorry. That's it. All right, it's going to be a problem. Yeah, there we go. And so, hang on, that's there. Yeah. I just have to see how important it's going to be. It's not the most important stuff, I suppose. Those are fine. Those are fine. Yeah. Let's see. Yeah. Okay. No, I don't think it's very important. So you have to do that with all of them. So basically, the domain and the range swap because it's x with y. So the range was, for it to be a function, was -1 to 1. So that's the domain for arcsine x. And the same with the range is the domain for the other one. Yeah, because it is yeah. So same with arc cos. So the convention is that it's between 0 and pi, and with tan, it just can take. The convention is the same as sine, between negative pi over 2 and pi over 2, and so that becomes the range. Those are fine. Those are fine. Okay. I think that's fine. I think that's fine. Yeah. Yeah, it cancels it out. So you would think so, but if you put it into your calculator, you don't get that. So if you do shift sine the sine of 100, oops, I'm in radians, degrees, it gives you 80, and that's because 80 is the principal value. And if you do 180 minus 80, you get 100. And it's basically, if we press S, if I put in, basically the sine of 100 is the same as the sine of 80. It just gives you the one that's closest to 0. So it's just for later. So this one, sine x is 2. Can you solve for x? Can you explain your answer? Yep. Yes. How do you solve this? Yep. So sine pi over 3, and it's root 3 over 2. How about this one underneath it? What is arcs for this one? Sine 2 pi over 3, and if you put that in, you don't get an answer, and that's because it is outside the range. So remember with our function, we said it's between pi over 2 and minus pi over 2. So this one, for arc sine x, 2 pi over 3 is too high up. It's higher than pi over 2. In the same way that 2 is higher than 1. They might give you the domain, and you would know the convention for the range. So these questions are fine. You can just put those in your calculator. It's just something to watch out for. Okay, so that's 5A. Next is 5B. Allegedly, we did this. This is this. Yes. How do we do these? A and B. Yeah. How do you do B? That's it. So the first one was root 2 over 2, and the second one would be 2 over root 2, and it just automatically rationalizes it. Yep. So they're all going to be fine. This one, hang on. So you know this thing that you have, sine x plus cos squared x equals 1. Sorry, sine squared x. Divide everything by cos squared x. What do you get? I believe it is sec squared x. Third letter. So that's an identity that you use. And what if you were to divide everything by sine squared x? Yeah, equals cosec squared x, and that's another identity that you use. I'll take your word for it. Yeah, that sounds about right. Yeah, this is Pythagoras actually. Sine squared x plus cos squared x is 1. Okay, how do we do this? I'll write it as divided by. Here's your two identities. Yeah. Yep. Mm-hmm. Mm-hmm. That's it. Because quod et rat demonstratum, it's like Latin for that which had to be proven has now been proved, something like that. It's like the tradition that the mathematicians write it at the end. So for these ones, so simplify means the answer shouldn't be a fraction, and the answer should be one thing, not two things added. So negative cot x is good, but sine x plus cos x is not, because that's two things being added. That would be cry time. Well, if you follow these steps, hopefully that won't happen. So step one is you deal with the highest power first. So you deal with sec squared x before sec x. Secondly, anything that has plus 1 or minus 1, change it into one thing. So tan squared x plus 1, change that into sec squared x. So from two things to one thing. And then the third is all of the reciprocals. So cosec, sec, and cot change into sine, cos, and tan. If you have a fraction of a fraction, just do it as one fraction divided by another. And do the keep change flip. But in general, it is highest power first, plus 1 or minus 1, change, and then the reciprocals change. So let's see. This is kind of a different thing. Let's see. I just want to pick a tricky one. One that has squared and stuff. Yeah, okay. So how about this one on the left? I think it was cosec. Yeah. Yes, sine cubed x. Yes. How about this one? I think it's sec squared. Let's take a look. So tan matches with sec. Okay. Sec. What is sec the same as? Yeah. Yeah. It's very common. Yeah, one. Prove these identities. Yeah. You can go wrong there. I want to do the one with this one. Yeah. How would we do this one on the left? To be what? You if when you have two things, you turn them into one. Yes. So if you rearrange that, it becomes cot squared x is equal to cos x squared x minus 1. And so that's cot squared x. And 1 over tan squared x. Yeah, it's not really... yeah, sorry, 1 over tan squared x. Yeah, go on. And yeah, that's the simplest one. It's cos squared x over, because it's just cos and sine as opposed to a reciprocal one. Any idea about this one? What would you get? So it has to be in a... You just basically expand the brackets. Yep. Yeah, so there's plus sec x and minus sec x. Mm-hmm. X, yeah. I think you could write it as sine squared x over cos squared x. Maybe that's simpler. I don't know. How about this? Nah, that's... I think it'd be fine. Yeah. That's an exam question, but it's okay. This one, I'm gonna... Yes, okay, how do we do this? Yeah, you can do that. Right? Root 5. It's also 1 over tan. Yep. So cos theta is adjacent over hypotenuse. So So sec theta is hypotenuse over adjacent. So there's root 5 over 2. However, have you seen this diagram? Yes. So if tan theta is 2, which quadrant are we in? 2 is a positive number. So we're in either of those. So if we're in the top right one, all three are positive. What if we're here? What about sec? Yeah, so imagine we're in the third quadrant, the tan quadrant. What would cos be for that one? Yeah. Yes, and so we'd have to say it's plus or minus, because we don't know which quadrant it's in. And then cosec. Yeah. How about cot? Yes, so that's the same. Well done. There's another way of doing it, but I could show it another way. Yeah, sorry, go on. Yeah. That's where it all comes from. So they told us tan theta is 2, therefore it has to be the first or third. No, that's why we have plus or minus, plus or minus. We just don't know, because it could be shift tan of 2. So it could be 63, but then it could also be answer minus 180. It could also be minus 116. We just don't know. Okay, so how about this one? Yeah. Not adjacent, sorry, for sign. Yeah. 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 No. Opposite over. That's sine. Now let me change the question. I leave out the first quadrant thing. Yes. So now, so you seem pretty good with that. Let me see. Tan is 1. The other way to do it, and I'll just show you, is you can square both sides. And so you can say sine squared theta is equal to 9 over 25. Sine squared theta is the same as 1 minus cos squared theta. 1 minus cos squared theta. And that way, so what would you get if you solve that? It is meant to be 16. Don't listen to me. Yeah. Yeah. And that gives you 9 over 25. What would you do next? And what would you get? And don't forget your plus or minus. And so you're getting plus or minus. And so we got the same answer using a different method. And so whichever one you prefer. Tan theta is sine theta over cos theta. And so you could just do sine theta is 4 over 5. And that's divided by plus or minus 3 over 5. And so you can do the keep change flip over 3. So that's 1. So it's plus or minus 5 over 4. Sorry, 4 over 3, which was what we got, etc. Yeah. And then you can just reciprocate them for the rest. So that one was plus or minus 5 over 3. And then the last one was just positive 5 over 4. So that's the other way, using the identity of sine squared plus cos squared. Both methods work identically. So there's nothing more you need to do with it. Chapter 5. And then this third one, I think we got to everything. And if we did, I could go to your book or I could go to chapter 4 for the modulus ones, just to make sure. So I remember we did these cosec ones, but did we get to everything? We didn't. I remember them now. Let me just check. So we got there. Yeah. I'm just going to skim. Yes. So match them up left or right. Which identity would you use for each thing? Mm-hmm. Yeah, I think that we just use that itself. Okay, so using those, let's solve it. So how would you solve this one, the tan one? Yes. How about the one over here? Plus 5. Okay, go on, keep going with this one. Yeah. No. Calculator. So what is A, what is B, what is C? Do it that way. And so what is equal to 4? What is equal to minus 1? So how would you solve these? Yeah, because you're trying to find theta. Yes. Yeah, and then you would just go from there. How would you solve this one? Yeah. Let's do it like that. How do you eliminate a fraction? Yes. And so that's how you do the fraction type. This one we did it. Those ones we did it. Solve this equation. I think it'd be fine. Although there's a lot to it. Don't bother. No, although there's a lot of work for this stuff, you have the method for it, and that's not the practice bit by substituting this in here. So I think you're gonna be fine there. This is what an exam question looks like. Do you want to do it? All right. Well done. Don't worry what where you getting. So you said it was work front ways. So you said you want to do it so it's 1 over sine squared theta. So divide everything by sine squared theta. Yes. So they were just looking for you to prove it. And honestly, if you don't remember it, just divide everything by sine squared theta. And if that's not the one, divide everything by cos squared theta. And okay, how about this one down here? Mm-hmm. Theta minus 1. Mm-hmm. So 5 and minus a half. So we want theta to 1 decimal place. Mm-hmm. Okay. Yeah. Is that 6 marks? Answers. How do you get an additional answer? Yeah. That's it. Okay. Good. Prove. Hence fine. Okay, let's try this proving hijinks. Yep. You can do that. What? So what is the common denominator? So this one has to be times that denominator. This one has to be times the other denominator. So what is the first fraction? And yeah. Yeah, I'm just going to leave it as cos x 1 plus sine x. Second fraction. So it's basically 1 plus sine x all squared. And so what do you get for that one? Yes, and I just brought them together under one denominator. What is next? You do not want to do that. You want to simplify the top. No. What if I rewrote the top as sine squared x plus cos squared x plus 2 sine x plus 1? Or let's say plus 1 plus sine 0. What is sine squared x plus cos squared x? Yes. So that becomes 1 plus 1. What is next? You want to fully factorize everything. Uh, 1 plus sine x. And what's that the same as? Yes. Algebraic fractions fully, so you add the two together, fully simplify, fully factorize, and then fully cancel down. For the how you simplify fractions, is it? So they don't give you that one, I don't believe. Maybe they do. I think you're expected to know that one. And I don't think they give you those. I don't think they give you those two, but they give you all the other ones. I might be wrong. Maybe they do give you those two, but I think they don't. The other ones is like there's a million of them. But so the only one you have to remember is sine squared x plus cos squared x equals 1, and then you just divide everything by sine squared x or divide everything by cos squared x, and that's how you get the identities. And this one didn't use any of them. Yes. All right. Part 2. How do we do this? What is 4 divided by 2? So sec x is equal to 2. So cos x is equal to? Yes. And then you just solve it from there. So the important thing is the hence. Just putting that together. So, okay. So technically we covered everything for that trig. I believe I might have... Yeah. Okay, and they're saying it's a reflex angle. And so it is there. And so what do you know about your answer for part 1? What about your answer for part 2? Yes. And so that's just the significance of that. Yes. So if you were doing your triangle thing, you might say, well, it is adjacent over hypotenuse. So that's 3 and 5, but you wouldn't write -3. You know what I mean? And similarly, if you did cos theta is equal to -3 over 5, if you square both sides, it becomes positive. And you then, when you find the sine thing, so sine theta would be plus or minus 4 over 5. But we said it's definitely going to be negative. And so we would say it is the negative one, not the positive one. Same with tan. It would be the positive one, not the negative one. It's just a different method for solving it instead of using the Pythagoras with the triangle. It's to convert cos into sine. So cos squared theta is 9 over 25. And so 1 minus sine squared theta is 9 over 25. Because it's a way to convert between cos and sine. The other way is to sketch the triangle. Yeah, so that's the significance with that, with the thing. So sometimes they'll actually lock you in with that. Yes. So cast diagram. Yeah, how was that for you, Gregoire? No, all right. Anything in particular you want to do next time? Did you want to do the chapter 4 stuff, did you say? Okay. Okay, and that's for our Monday one, is it? Okay. Yeah. Okay, any questions for me in general? All right, well done, Gregoire. You did great, and good luck on your test. All right, have a good one. Good night.